Okay, now for Pythagorean identities, and these are a little bit more difficult. First off, one thing I want you to think about is this here. We have sine squared plus cosine squared. Now I do remember this. Sine was y on the unit circle, cosine was x. And remember the unit circle, r squared would be since the 1. There's a little hint there about what's going to be coming on. Let's look at some stuff here. As we look at this right here, remember sine is what? Opposite over hypotenuse, and cosine is adjacent over hypotenuse. So let's take opposite over hypotenuse squared plus adjacent over hypotenuse squared. Well, what's going to happen is this. I have to, if I put them together, I have opposite plus adjacent equals the what? Hypotenuse squared, right? Okay. Now think about it. Isn't the opposite plus the adjacent also equal to the hypotenuse? So if you have the hypotenuse over the hypotenuse squared, guess what you're going to get? 1. Like the loneliest number that you'll ever see, the little beetle's still there. So sine squared plus cosine squared equals 1. There's proof, one way of proving how it works. Are there any other Pythagorean identities? Ooh, I'm glad you asked. Because think of this, let's try 1 plus tangent squared, and let's see what it makes. Well, first off, tangent is what? Sine squared over cosine squared. Now what I did was this here. Because I had a cosine here, I wanted a cosine in my denominator. And how can I get 1? Well, if I take the same thing and divide it by the same thing, isn't that 1? Well, yes it is. So I just changed the way the 1 looks to a cosine over cosine. And if I square it, this cosine over cosine still divides to make 1. I square it, it's still going to be even 1, right? Because 1 times 1 is 1. It's not going to change anything. So now that I look at this, I have cosine squared plus sine squared over a cosine squared, right? Because the squared goes to both of those, both there, both there. Well, we already know that cosine squared plus sine squared is equal to what? 1. And from our reciprocal identities, 1 over cosine squared I know is secant squared. So 1 plus tangent squared is equal to secant squared. So there's another little Pythagorean identity we just proved. And there's one more. Now what is going to happen on this one? It's going to kind of be the reciprocal of the other one. So this time cotangent, remember, is cosine over sine, but I have it squared. And because there's a sine here, I'm going to make my common denominator a sine right here. And if I, doesn't matter if I square it because it's still going to be 1. That divided by that's 1, and 1 squared is still what? 1. I haven't changed the value, I've just changed the way that it looks. 1 looks like that. Okay? It's kind of whether you're looking at me from the front or looking at me from the back, you know, or from the side. I used to be skinny when you looked at me 30 years ago. Now I look a little fatter like this one. All right? But anyway, so if I put those together, I have a sine squared plus cosine squared on top and a common denominator of sine squared on the bottom. We already know what sine squared plus cosine squared equal to? 1. And then 1 over sine squared is the reciprocal for the cosecant squared. So 1 plus cotangent squared equals cosecant squared. Alright, yay! A big hint, remember sine squared plus cosine squared is 1. Okay? So then the cotangent starts with the c. 1 plus cotangent squared equals the one with another c started cosecant squared. Because cosine's already gone with sine. And then that helps you figure out that 1 plus tangent squared goes with secant squared. So